All right, here we go. The homework for today. Pretty quick class today. We're going to just do the reverse of what we did yesterday, do a couple word problems, and that should be it. All right, here we go. Two objectives. So yesterday we took linear inequalities and we graphed them. Remember, it was a 5-step procedure. To do this, we graph the y-intercept. The y-intercept here is 2. We graph the slope. The slope is 3 over 1, so up 3 over 1. Do that a couple times. If you want to go in the opposite direction, down 3 over 1. We determine whether it's a solid or a dashed line, dotted line, and this one is a solid line because look at the greater than symbol. It's got a line underneath it. If it has a line, you put a line. If it doesn't have a line, you put a dash. Now we pick a test point. We like picking 0, 0. You can always pick 0, 0 as long as that black line that you just drew doesn't go through 0, 0. If it goes through 0, 0, you got to pick a different point. You can pick any point as long as the line doesn't go through it. We like 0, 0 because it makes the math easy. That's 0 for y and 0 for x. We take the equation. 0, 0 is on that side of the black line. You see that? We take 0, 0. We place 0, 0 for y and for x. 3 times 0 is 0. And 0 plus 2 is 2. And now we see if that is a true or false statement. 0 is not bigger than 2, nor is it equal to 2. So therefore, the side of the black line where 0, 0 is on, I'll call that the right side, is not the correct side. It would be the other side that is the correct side. So you shade that side. So that was last night's homework. Today, we're going to do the reverse. Today, I'm going to hand you this picture, and you're going to write the inequality. So how do you do that? So we're basically switching. So I'm going to give you this, and you're going to write that. I'll walk you through how it's done. All right, quick reminder. If we're talking about all lines except for vertical lines, all lines are of the form of y equals mx plus b, where m is the slope and b is the y-intercept. For horizontal lines, we have a shortened version of that because the slope is 0. 0 times x is 0. So we're just left with that b value. Now, you might be saying to yourself, why doesn't it say y is equal to b? It could. K just is any number. Lastly, vertical lines of the form of x equals k. Now, none of this is new. That's all review stuff. So we're going to use those 3 examples right there for our base equations. One of the steps is going to say, write the base equation. If the graph I hand you is a diagonal line, you're going to write y equals mx plus b. If the line I hand you is a horizontal line, you're going to write y equals k. And lastly, if the line I hand you is a vertical line, you're going to write x equals k. Okay, so here we go. I'm handing you a graph. It has a linear inequality on it. Step number 1 is to figure out which side is shaded. All right, so the colored side here, to me, that looks like it's yellow. So the right side of that red line right there is the shaded side. So here's the process. Step number 1, we're going to write the base equation. The base equation is one of these 3 equations. Do we have a diagonal line? Do we have a horizontal line? Do we have a vertical line? We have a diagonal line, so the base equation is y equals mx plus b. So I write y equals mx plus b. Step number 2. Let's figure out if what the, I'm going through the 3 possibilities here. So of those 3 possibilities, diagonal lines are y equals mx plus b. All right. Step number 2, pick 2 points. Be smart on the 2 points that you pick. We're going to pick 2 points on that red line right there. One of the points should be the y-intercept right there. The other one could be any other point on the line. I'm going to pick that one right there. From those 2 points, I can find the y-intercept, and I can also determine the slope. So let's see. The easy one is the y-intercept. The harder one is the slope. To calculate the slope, I'm going to go from the left circle to the right circle and stay on a line. So let's see, if I count the number of squares to go from the left circle to the right circle, I'm going to draw this for you, and I stay on a line. I'll do this in blue. Let's see, if I start right here, I would need to go up 1, up 2 squares, and go to the right 1 square. So I went up 2 and I went right 1, and that is your slope. Remember, slope is rise over run. So the slope is 2 over 1, which is 2. So the m value is 2. Okay. The y-intercept is easier. The y-intercept is where the red line crosses the y-axis. Well, it crosses right here. We picked one of those points to be the y-intercept. So the y-intercept is 1. I'm just counting the number of squares, 1 square. We're going to take those two answers of slope is 2 and the y-intercept of 1, and toss those in to the appropriate spots. And the appropriate spots are for the y-intercept, that's your b value, and for your slope, that is the m value. Write the final equation, and we get y is equal to 2x plus 1. And if this was just a line, then we would be done, except it's an inequality. So we have to do that last step there of accounting for the fact that it's an inequality. So two things I got to do. One, I got to figure out if it's a solid or dashed line. And then two, I got to figure out which side is shaded. So let's do that. So the steps are: pick a test point and make sure your test point is in the shaded area and simplify. So the shaded area is in the yellow. We certainly would love to pick 0, 0, and notice 0, 0 is in the shaded area. So I'm going to use 0, 0. I take that value 0, 0, and I toss it back into the equation I just wrote. So I have 0 is equal to 2 times 0 plus 1. 2 times 0 is 0, so I'm left with 0 is equal to 1. Now that is clearly a false statement, so we need to make it into a true statement. So how do you make 0 and 1 into a true statement? I have the option of using a less than symbol. Oops, sorry. I am on the last step, choose a sign. So I have the option of using a less than symbol, a greater than symbol, a less than or equal to symbol, or a greater than or equal symbol. I look at the red line that's on the graph. It is solid. If it is solid, it narrows down our choice to this or this symbol. I choose which one of those makes this particular statement true. And there's only one of them. If I choose the greater than or equal to symbol, 0 is not greater than or equal to 1. However, if I erase all this, the less than or equal to symbol would make it true. So that's my final answer. Now, where did that come from? Remember, the base equation turned into this, and now all I have to do is figure out what symbol replaces the equal sign. I get that by looking at whether the line is solid or dashed, and I get that from what side is shaded. Pick a test point. I picked a test point, and I needed to make that into a true statement. And there's only one symbol, right? I can't use this one because it has a line underneath it, and the line is solid. So I'll have to use, I can't use this one because it doesn't have a line underneath of it. I have to choose the less than or equal to symbol. That is the process. We're going to do a couple of these, and then you should be good to go. Okay, let's do another one. Step number 1, write the base equation. Is it a diagonal line? Is it a vertical line? Or is it a horizontal line? It is a diagonal line. So of these 3 base equations, we're going to use that one right there. Now I need to find M and B. I pick 2 points. Let one of them be the y-intercept. So I'm choosing 2 points. Remember, you're choosing a point that's on a lattice intersection. That's where the lines come together. Okay, calculate the slope. So from those 2 black circles right there, just count the number of squares that it takes to get from the left circle to the right circle. So I'm going to go up 2 squares and over 2 squares. So my slope is up 2 over 2, which could be reduced to 1. So the m value is 1. To find the y-intercept, well, the y-intercept is the left dot right there. It's where the line crosses the y-axis. So my y-intercept is -1. So my y-intercept is negative. There's no math involved there. I'm just looking at the graph. I take those 2 answers, 1 for the slope, -1 for the y-intercept. In other words, 1 for m and -1 for b. I just toss those values in. You're probably saying, what happened to the 1 for slope? Well, remember, 1 times x is 1x, so we don't have to write that 1. There is my equation. Now I turn it into an inequality by picking a test point. So let's see, if I pick a test point in the shaded area, I pick anything in the shaded area. So I'm picking 2, -2. So 2, -2 is that point that I just circled in red. I throw those values in to the equation for both y and x. Remember, 2 would be your x value, -2 would be the y value, and I take those values and toss it into that equation right there and rewrite the equation. Oh, I actually did that. Well, you know. Okay, didn't think I did that. So toss those in. Y is -2, x is 2. Simplify this. 2 minus 1 is 1. Clearly, that's not a true statement, so I need to make it into a true statement. Look at the red line. It is dashed. So if it is dashed, we only have 2 possible signs, right? The 2 possible signs, since it's dashed, are less than or equal to. Because remember, -2 is smaller than 1. So since it is dashed, I choose the one without the line. That is the less than symbol. Toss that back into the equation I wrote over here with a less than symbol, and I'm done. So y is less than x minus 1. It usually takes about 3 of these for this to lock in. Let's knock one more out. Okay, so here we go. Step number 1. Is it a diagonal? Is it a horizontal, or is it a vertical? It's a diagonal line, so y equals mx plus b. Okay, choose 2 points. So let's see, which 2 points I'm going to choose. I'm going to choose this point, that's the y-intercept, and I'll choose this point. There's lots of, I could choose this point, I could choose this point. I'm just going to choose 2 of them, the 2 convenient ones right there. Calculate the slope. So I'm just simply counting how many squares I'm going up. I'm going up 1 square, and I'm going to the right 2 squares. So my slope, the m value, is up 1 over 2. My y-intercept, I'll do this in red, my y-intercept is right here, and that is the value 3. So my equation is y is equal to 1/2 x plus 3. Now I pick a test point in the shaded area. For me, I don't try to make it complicated. I want to make sure I reduce the chances of making a simple mistake. So I'm going to choose -5, 5. That's my point. So let's see, -5 is the x value, and comma 5 is my y value. So -5, 5, and I'm going to toss those values into my equation. It says y is 5. Let's see, -5. So that'd be -5 times 1/2, which is -5 over 2 plus 3. Now, if I have that math right there, let's see, I need to simplify -5 halves plus 2. So that means I need to turn 3 into a fraction that has 2 at the bottom. So I'm going to multiply the top and the bottom by 2. And that would give me 5 is equal to, let's see, 3 times 2 is 6. -5 plus 6 is 1. 2 times 1 is 2. The common denominator is 2, so I get 1/2. So I get 5 is equal to 1/2, and I need to make that into a true statement. So if you'd like, you can now erase this equal symbol and figure out, well, what symbol would you have to do to make that true? Well, there's 2 symbols that can make it true. Let's see, 5 is way bigger than 1/2, so it's either this symbol, greater than, or it's greater than or equal to. It's a solid line right here, so it's got to be greater than or equal to. So take the greater than or equal to symbol, let me do this in blue, and throw it in to the equation that we just wrote right here, and that's our final answer. So our final answer is y is greater than or equal to 1/2 x plus 3. And that's the process. Hey, we didn't do any of those special ones, vertical or horizontal lines, right? So let's do a couple of those. Hey, I got a vertical line. We know from a resource card that vertical lines are not diagonal, right? So it's not that one. They are the form of x equals a number. So what is that number? Well, what is it going through? It's going through, let's see, let me draw this for you. It's going through right here, and that's the value 2. So that means x is equal to 2. Now it is a dashed line. So let's see. I got to pick a test point in the shaded area. So 1, 1, 2, 2. I'm going to pick 3, 3, right? Oops, sorry. I'm going to pick, well, actually, I picked 4, 0. So let's throw in 4, 0. So let's see. 4 is my X value and 0 is my Y value, but I only have an X value. So I write, I'm sure I did this on the PowerPoint. So instead of having some horrible writing right here, let's just toss this in. So, yep, I did that. Toss that in for 4. So 4 is equal to 2. And I need to make that into a true statement. There's only 2 symbols that could make that true, either greater than or equal to, because 4 is bigger than 2. Since it's a dashed line would only mean this symbol right here. If it was solid, I would choose greater than or equal to. And I'm going to take that value, that symbol of that, and I'm going to toss that back into way over back to here, into that right there. So toss that in, and we get X is greater than 2. And that's how it's done. Okay. Only thing left is a real world problem. So let's do a real world problem. Let's see. An interior decorator is going to remodel a kitchen. The wall above the stove and the counter is going to be redone as shown. The owner can only spend 420 or less, less than or equal to. Write a linear inequality and graph the solutions. What are 3 possible prices for the wallpaper? So I got tiled area and I got papered area. I can only spend $420. So if I let Y equal the cost of the tiles, let's see, tile area, it says right there is 12 square feet. And if I let X is equal to the paper area cost, and I've got 24 square feet of that, then it would be, let's see, I need 12 times the cost of the tiled, because there's 12 square feet of the tiled, so that'd be 12Y, plus 24 times the cost of the paper, that'd be X, and I need that price to be less than or equal to $420. It could be exactly $420, but it can also be less. So I need to graph that, and we got a problem because Y is not by itself. So I'm going to do a little bit of algebra. I'm going to get Y by itself. So I'm going to subtract 24X from both sides. I'll get that. And then let's see, I got to divide everything now, get Y by itself, divide everything by 12. So if I divide everything by 12, let's see, the 12s would cancel on the Y and be left with Y. Negative 24 divided by 12 is negative 2. And 420 divided by 12 is 35. So there's my inequality. That is what I'm going to graph. So I'm going to take that graph of that right there. Ooh, I got a y-intercept of 35, but I only have 10 squares going up. So I can't get to 35 unless I make each square worth a different value. So if you wanted to, instead of, I just put 35 squares right there. So if I didn't want to do that, I would have to make each one of these tiny squares worth a different value. Eventually, you would get the graph. Let's see, the slope is negative 2 over 1. The y-intercept is 35. And let's remember what each one was. Y was the tile cost, and X is the wallpaper cost. And everything in red is a solution. So it says, what are 3 possible answers to this, right? So any 3 values for it would work. I'll just pick 3 at random. Let's say that you want to spend, you found wallpaper that cost $5. Well, then how much would you be left over to spend on your tile cost? I would look straight up until I hit the line and then look straight over. And so how much could you spend on tile? Not $25, but $25 per square foot. So one possible answer would be if you spend $5 per square foot on wallpaper, you could spend $25 per square foot on your tile. So there's one possible answer. I'll just pick 2 more. Any order would be fine. Let's say you want to spend $10. Clearly, we're going to have less money to spend on our tile. So if you spend $10 on the wallpaper, you could only spend $15 on your tile. So another possible answer, I almost wrote a 5, would be 10, 15. I think you can see how this is going. Lastly, I'm just picking just any values. We'll go for 15. So if you choose 15, that's pretty expensive wallpaper. If you choose $15 per square foot on wallpaper, then you can only spend $5 per square foot on tile. So if you're a contractor, you're very familiar with something like this, you have a total budget and you have to figure out how much of you have two things that you have to complete, then you would use a chart like this to help you for that calculation. So if you spend $15 per square foot on wallpaper, you only have $5 per square foot that you have left to spend on your tile. There we go. Now there's lots of answers here. I could have picked any value there, just gone up to the line and gone straight across. Okay, so that will do it for today. Once again, I'll end on the homework slide. Here is your homework slide. If you have any problems, come see me. And I think this is the last class. I'll see you back in class on Monday. Be good and have good behavior.